Okay, we're going to finish up lesson 3 of Unit 10, and this is actually the last lesson of the unit, so we're wrapping up Unit 10. But for today, what you're going to need is you're going to need your Properties of Exponents flip chart, as well as your Unit 10 notes packet, and we're going to use both of them, so make sure you have them both ready to go. What we're going to do first is we're going to do the dividing tab on your Properties of Exponents flip chart. So that's the pink tab. We started division of exponents in the last section, so hopefully this will be familiar to you, but you're going to want to have this in your flip chart so that you can use it as a reference for any quick checks or for your unit test that's coming up in a couple days. So to divide, the terms must have the same base, and when dividing, the base stays the same, and you subtract the exponents. I'll fill that in a little bit, but that's what we learned in the last lesson, is that to divide two powers with the same base, you'll subtract the exponent. But remember, when in doubt, write it out. So we're going to look at the first couple examples here. First one, x to the 5th divided by x to the 2nd. So first, x to the 5th, I'm going to write it out. That's x times x times x times x times x, and then divided by x to the 2nd. So that's x times x. Remember, when I have x divided by x, that's 1. So that's why I can draw a line through the two. That equals 1. And then x divided by x equals 1. So what I have left over is these three x's here, which would be x to the 3rd power. Remember, if I subtract the exponents, 5 take away 2 is 3, and so that's where the rule comes in for dividing exponents. But when in doubt, write it out. And in your flip chart, you're going to want to have it written out so that you can see why it worked to subtract the exponents. Second one, 3 to the 5th divided by 3 to the 3rd. So first, 3 to the 5th is 3 times 3 times 3 times 3 times 3, and divided by 3 to the 3rd, 3 times 3 times 3. Okay, I have 3 3's on the top and 3 3's on the bottom that will divide to equal 1. So what I'm left over with is 2 3's, or 3 to the 2nd power. And I want to keep simplifying here. I know 3 to the 2nd power is 3 times 3, which would equal 9. So again, that exponent, subtracting 5 take away 3 is 2. Okay, now next one, it gets a little bit more complicated because we have two different factors. We have x's and we have y's. So in the numerator, I have x to the 2nd, y to the 5th, denominator divided by x, y to the 3rd. So in the numerator, x to the 2nd is x, x, y to the 5th is y, 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 and y, and then divided by x, y to the 3rd. 1, 2, 3. Okay, now let's take a look at what we can cancel because it equals 1. So x divided by x equals 1. And then my y's, I have 1, 2, 3 of them. Okay, so now it gets kind of messy. You got to look at what you have left over here. We have an x, so that's x to the 1st power. And we have two y's, so that's y to the 2nd power. Okay, next one, p to the 4th divided by p to the 6th. Numerator, I have p to the 4th, 1, 2, 3, 4, divided by p to the 6th, 1, 2, 3, 4, 5, and 6. Now pay close attention. P divided by p is 1, again, again, again. However, this time I was left with, let me back up one second here. This time I was left with p to the 2nd in the denominator. So you have to pay attention. There's nothing actually left in the numerator, where before, in all of the other examples we've done, everything was left in the numerator. Okay, and really in the denominator, I could have put a 1 in all my denominators, but I don't need to write over 1 for all of my expressions. So in this one here, there's nothing left in the numerator, but I need to have something there. So it's 1 over, in the denominator, I have p to the second. Okay, now let's take a look at why p to the second ended up in the denominator. If I go back to the rule where I subtract the exponents, 4 take away 6 is -2. Okay, so that would be p to the negative second if I apply the rule. Well, p to the negative second, when I flip it to make it a positive exponent, is the same thing as 1 divided by p to the second. It's the reciprocal. So that is why we have 1 divided by p to the second. It's also the same thing as p to the negative second. So you can still apply the rule. You'll just have to make sure that you rewrite using a positive exponent if your answer was a negative exponent. And last one, 3x to the third, y to the fifth, divided by x to the seventh, y squared. So first, I have 3x to the third. The coefficient is 3, so I write 3 and then x to the third. X, y to the fifth, 1, 2, 3, 4, and 5, divided by x to the seventh, 1, 2, 3, 4, 5, 6, 7, and then y to the second, y. Now let's look at what we can cancel out here. So first of all, I have a coefficient of 3, and there's nothing to divide 3 by in the numerator. It's 1, 3 divided by 1 is 3. So I would be left with a 3. Okay, now when I look at my x's, I have 1, 2, 3 that will cancel, and then I have 4 left in the denominator. Then when I start to cancel my y's, I have 1, 2 that will cancel, and 3 y's left in the numerator. So now when I go to write my expression, I see I have my coefficient of 3. And then for my y's, I have y, so that would be y to the third. And then in the denominator, I have the 4 x's, so that would be x to the fourth. Okay, again, we'll look at why did we end up with y to the third in the numerator and x to the fourth in the denominator. Well, if I look at my x's, if I take 3 and I subtract 7, 3 minus 7 is -4. So that would have been x to the negative fourth, but then I need to flip it, and so x to the positive fourth goes in the denominator. For the y's, I did y to the fifth minus y to the second. So 5 take away 2 was 3. So y to the third doesn't need to be put in the reciprocal because it's already positive. So that's why we end up with y to the third. Okay, so go ahead and fill in the top. It says to divide, the terms must have the same base. And when dividing, the base stays the same and you subtract the exponents. Okay, we're going to move on to the notes for 10.3. So the essential question is, how can you divide two powers that have the same base? And remember, to divide powers with the same base, you subtract their exponents. So this should be becoming familiar to you. For example, if you have 4 to the fifth divided by 4 to the second, you subtract the exponents of 5 minus 2, these exponents, and then you keep the same base of 4. 5 take away 2 would be 3. So you have 4 to the third power. So we're going to do some examples here, but when in doubt, write it out. We are not going to keep writing it out. If you need to, then you should. Like in your flip chart, you wrote it out in expanded form, and then you were able to visually see which terms would cancel out. If you need to do that, then you keep doing it. For what we're going to do, we're just going to subtract the exponents. The directions say simplify each expression, and you need to write your answer as a power. So we're not going to convert it to a number after you find the power, is what that means. So for A, you have 2 to the sixth divided by 2 to the fourth. So I look at my exponents. Since the base is the same of 2, I have an exponent of 6 and 4. I subtract them. 6 take away 4 is 2, so my exponent is 2. I have 2 to the second power. And I'm going to leave it like this. It says write it as a power, so I don't need to say equals 4. Just leave it as 2 to the second. For B, I have -7 to the ninth divided by -7 to the third. So I look at my exponents, 9 and 3, subtract them, which is 6, and then keep the same base, negative 7 to the 6th power. For C, I have h to the 7th divided by h to the 6th, same base, so subtract the exponents. 7 take away 6 is 1, so I have h to the 1st, or just h. Now, example 2, you're going to use multiple exponent properties to simplify here. So it says simplify the expression, write your answer as a power again. For A, notice we have 3 to the 4 times 3 to the 2nd, and I have to do that part before I divide it by 3 to the 3rd on the bottom. So 3 to the 4th times 3 to the 2nd, that's multiplying exponents, so that the rule is to add the exponent. 4 plus 2 is 6. So in the numerator, I have 3 to the 6th. Then I'm going to bring over 3 to the 3rd and keep that as the denominator. And now I'm dividing these powers here. So the rule is to subtract the exponents. 6 take away 3 is 3, and my base stays the same, 3 to the 3rd power. For B, I have 2 to the 15th on the numerator, but in the denominator, I have 2 to the 3rd times 2 to the 5th. So I need to simplify that part first. 2 to the 3rd times 2 to the 5th, that's multiplying, so the rule says add those exponents. 3 plus 5 is 8, so I have 2 to the 8th in the denominator. In the numerator, we have 2 to the 15th. Okay, then this is a dividing power, so the rule is to subtract the exponents. 15 take away 8 is 7, so I have 2 to the 7th. Now for C, I have to simplify the top and the bottom, and then I can divide. So for the numerator on C, m to the 13th, whoops, 1 second here, m to the 13th times m to the 5th. The rule is to add those exponents, which would be 18. 13 plus 5 is 18. So I have m to the 18th in the numerator, and then in the denominator, m to the 7th times m to the 10th. 7 plus 10 is 17. So I have m to the 17th. Okay, now I'm dividing powers here. So subtract the exponents. 18 take away 17 is 1. So I have m to the 1st, or just m. Now for D, I have a dividing powers times another dividing powers. So first I'm going to take care of what 7 to the 5th divided by 7 to the 3rd is. So take my exponents of 5 and 3 and subtract them, and I get 2. So I have 7 to the 2nd. And then in the second factor, I have 7 to the 12th divided by 7 to the 6th. So take my exponents, 12 and 6, and subtract them. 12 take away 6 is 6, so I have 7 to the 6th. And then I need to multiply these two together, so I look at my exponents, 2 and 6, and I add them together. So I have 8, 2 plus 6 is 8, so I have 7 to the 8th. And for E, same thing here. I have two factors that I have to divide first, and then I'll multiply them together. So g to the 10th divided by g to the 3rd. Take my exponents of 10 and 3, subtract them. 10 take away 3 is 7. I have g to the 7th, and then times g to the 32nd divided by g to the 28th. So I need to subtract those exponents. 32 take away 28 is 4. So g to the 4th. And then I need to multiply them together, and the rule says I will add my exponents. So 7 plus 4 is 11. So I have g to the 11th. Okay, for example 3, we're going to again use multiple exponent properties to simplify completely. So it says simplify each expression including all numerical powers. So that means instead of leaving something like 3 to the 2nd, you would rename it as 9. So for A, let's take a look. We've got 5 to the 10th times m to the 5th. Now you might be thinking, oh, I need to simplify the top. But you can't because you don't have the same base here. 5 and m are not the same base. So we kind of leave that alone for now. And then we look at what we can maybe divide out for powers. So I notice I have 5 to the 10th divided by 5 to the 6th, okay? So I can simplify that, apply the rule of subtract the exponents. 10 take away 6 is 4. So I have 5 to the 4th, and then I'm left with m to the 5th. M to the 5th does not have any m's in the denominator, so I'm not dividing it by any of the same base. So I keep it as m to the 5th. Okay, now I need to simplify the 5 to the 4th because that's a numerical power. So I do 5 to the 4th, and I get 625. So I write it as 625 m to the 5th, and that is your final expression. For B, if we take a look in the numerator, we have a to the 7th times d to the 12th times 12 to the 3rd. None of these have the same base in the numerator, so I cannot simplify these and combine them on the top. In the denominator, I have d to the 7th divided by 12, so these don't have the same base either. So let's start to look and see if we can maybe divide out some powers. I look at a to the 7th. I don't see any other a's in the denominator, so I'm going to write a to the 7th in my final expression, just like we wrote m to the 5th in the other one. So I write a to the 7th. Then I look at d to the 12th divided by d to the 7th. Well, when I look at my exponents, 12 and 7, and I subtract them, apply the rule, 12 take away 7 is 5. So I have d to the 5th. Okay, and then I notice I have 12 to the 3rd divided by 12, which is actually 12 to the 1st. So these are the same base, so I can apply the rule, subtract the exponents. 3 take away 1 is 2, so I'll have 12 to the 2nd, but I'm going to write that out front because our coefficients always go out front. So 12 to the 2nd. Okay, then I have to simplify the part, rename it for 12 to the 2nd. 12 times 12 is 144. So I have 144, a to the 7th, d to the 5th, and that is your final expression. Okay, for C, I have m to the 14th, m to the 14th times d to the 12th in the numerator, which those are not the same base, so I can't multiply them. Denominator, m to the 3rd divided by d to the 6th. So if I look at my m's, m to the 14th divided by m to the 3rd, subtract those exponents. 14 take away 3 is 11, so I have m to the 11th. And then for d to the 12th divided by d to the 6th, subtract the exponents. 12 take away 6 is 6, so you have d to the 6th. So your final expression is m to the 11th, d to the 6th. Okay, for D, we have b to the 6th times r to the 8th, not the same base, so I can't multiply them, divided by b to the 11th times r to the 5th, again, not the same base, but let's see if we can divide some powers here. So b to the 6th divided by b to the 11th. Be careful, subtract. You always, always, always have to do numerator minus denominator. So when I do 6, take away 11, that is negative 5. So write b to the negative 5th. We will clear up that negative in a little bit. Then I look at r to the 8th divided by r to the 5th. 8 take away 5 is 3, so I have r to the 3rd. Now, this could be our final expression, but this negative 5 with the b is not okay. So we need to change that into a positive exponent, but I am only going to change b to the 5th to be positive. R to the 3rd is going to stay in the numerator, and I'm essentially going to flip the b to the 5th to the reciprocal, which would be putting it in the denominator. So b to the 5th is going to be in the denominator. R to the 3rd will stay in the numerator. So I'm going to write my new expression. R to the 3rd stays in the numerator. B to the 5th goes to the denominator and is now a positive 5 instead of negative 5. We need positive exponents only.